Hello everyone, welcome back. This is the usual stream for writing a programming language in Rust. Today I'll be doing as I've been doing recently and just diving right in. There have been a number of, tricky edge conditions in the refactoring that's been happening recently. So that refactoring is mainly to do with how we handle assignments in the language. Now, it's been functional before, but essentially what had been happening in the previous implementation was that we would essentially have these memory areas. I was calling them boxes, even though box is kind of a reserved term in Rust for a specific data type, but just conceptually we had these boxes that were containing values in the language that's being implemented here called seed. And essentially what was happening was that when I would update a value, I would essentially replace that box with a new box, which then contained the new value. And that worked fine. All the tests were passing as expected. There were some other edge conditions that got flagged as I was working on this stuff, but that was kind of separate. But essentially the improvement that I was looking to make was to, instead of replacing the entire box when an update happened, instead replace the value inside the box. And in theory that would make things a little bit more efficient and potentially make things a little more intuitive. Perhaps there were other edge conditions and edge cases that I hadn't considered or hadn't covered by test that might be handled a little better with this new mechanism, but that remains to be seen. Now, there were different issues raised or flagged by different tests as I implemented these changes. And the most recent one is almost the opposite of another edge case that had been flagged recently, which is what had been happening before is that whenever an object got assigned to a new variable, it would essentially perform a shallow copy on that object, so that modifying the new object, in theory, that should affect the original object, because in theory we should be copying references, not shallow copies. If you wanted to do a shallow copy, you can, but you have to do it explicitly to create a new object, or at least a shallow clone of the object, or a shallow copy of the object. Whereas sharing these references, we should be able to update the old reference. And that wasn't working as expected because a clone was being performed whenever an object got assigned to a new value or declared as a new value. And so that got resolved in this area here that we're looking at the moment, and that we're kind of still debugging. There's lots of debugging symbols around the place. But now we have essentially the opposite problem, or not necessarily the opposite problem, but we are now handling those references properly. So if I create an object in X and if I bind Y to X and I update Y, then X will also be affected. So that does what we want with objects. However, we also found the same thing happened when we had, when we had regular variables. So if I assign one to X and then I assign X to Y and update Y, we found in the tests, as we can see over here, this is the actual test output, again up here are debugging symbols, but we have 2 instead of what we would expect, which is X to contain the original value. And as we were digging into the details of that as well, we can see that in these areas where I have these 3 angle brackets, basically we have an arc mutex value here that we've assigned to x, and very explicitly we call clone on that arc mutex, so we get a new reference to the same value, and then we assign that to y. And this was just something I wanted to understand a bit better, and we could see clearly that even though it's a clone, again, there is perhaps a level of abstraction that Rust performs that I'm still not fully familiar with. If this was something like C, where you're, I would say, much closer to, like, the abstraction is much lower, I would say. You're not really as far removed from the runtime. I would have a bit more certainty about exactly what's happening here, because it's dealing with arc mutexes, and I'm not sure how memory addresses in Rust actually translate to working memory. But at least from what we can see here, the reference, even though we've cloned that arc mutex and presumably its reference count has incremented, we're still dealing with the same memory item. So when we clone a reference and put it into a new variable like y, and then modify that, we're still actually modifying the same reference as before. So whether it's the right approach or not, a part of me thinks that this might be a bit of a hacky approach, but the solution that I have been thinking about at the moment is something kind of simple like this. So let me just double check, is value imported? It is. So if I essentially just check if the value, so if I lock, I would say y, and unwrap it. Basically, if I check the value of the item that's being, and we're in a declaration here. I should probably do this with assignment as well. But essentially what I'm going to be doing here is checking the type of value that is being declared, and if it's a reference type like an object or a list, then we'll clone the reference. But then if it's not a reference type, then we will clone the value itself. So let's take a look here. So we'll go, if that's the case, and what we can say is that y in this case is going to be if is object. In fact, we can do it like this. I'm partly just remembering a little bit of work that I had done on this prior to today's stream. So if it is an object, then we're basically just going to use, oh no, we need to release that lock first. So what we're going to say is if it is an object, then we will just use x as is, that arc mutex. Otherwise, and I'm going to be rectifying the names here shortly enough, but for the moment we'll do something like this. We'll do lock unwrap, and then arc new mutex new x. So we're explicitly creating a new in-memory location, as opposed to before where we were just cloning the arc mutex and, at least in my head, creating a new one, a new reference memory space, but that wasn't quite how it worked. Can I do that? Oh, actually, x underscore. And in theory, what we should hopefully be seeing is that we have the same value in both places, but in the updated code, the addresses will be different. So I'm just going to take a quick look at some code that I had saved from before. Did I clone the value inside? Yes, I did. So yeah, if it's not an object, then we do actually manually clone the item inside the value. And so first of all, we can see that this resolves our problem that we had before. So instead of being 2, 2, it's now 1, 2 as we expect. And we can see that, let's see, that's copying print. Here we have the value, and we can see that it's the same value, but in 2 different places now. And so with that, there will be a number of tests to update. I'll want to check this with lists as well to make sure that the same behavior that we get. So lists weren't displaying the same problems that objects were displaying. So we'll take a look at that, and I wonder if assignments will have the same issues as declarations, but how to trigger those distinct cases, I'm not quite sure off the top of my head. But let's go ahead and handle, or even just put some of these different tests into their own test cases. So we have parameter mutation, and this was showing an issue that again was similar to this one, where modifying a parameter actually modified the variable that it came from. So in this case we would be expecting the output to be 1. Is this the same test? Kinda, but it's in the other direction. So what I'll do is the same output. And what I'll do is also comment out all these print lines so that tests will actually pass. So that was that, and we'll run all the tests now. And while I'm waiting for that one to resolve, where did I put new tests? In the last. Yeah, so there was nested prop assign, there was prop assign. So what I might do is index assign. And should that be in? I'll create a new test file called objects. We would expect age to be 30 in both of those scenarios. And same in this case, but it was the case that previously this test would work and this test wouldn't, so it's handy to include both. And this last one I'll just put into variables because it's kind of standalone. In this case, both lists X and Y should contain the same value. So with those all done, I could see before that there were some test failures anyway. So, okay, and this one just seems to be working now. Kind of surprised by that. I would have thought that I would have to copy the references for that as well. That's interesting. Okay, I'll come back to that one. In the meantime, we'll focus on the main one that failed, the main new one that failed anyway. And so it's assigned to, and in this case the output is 2 1. Okay, so that's just a case of me ordering them incorrectly, but the functionality actually works, so that's okay. Now this case I'm a little surprised by. So we'll take a look, because, and the reason I'm surprised by it is I would have thought that, and actually what was that Clippy? Okay, so you can actually do if matches to do a pattern match. That's interesting. It's a little verbose, but that's fine. Oh dear, that's a lot of debugging output, so I'll just run this with assign 1. No, what was the test that failed before? Oh, I'm never going to be able to find that. I'll comment out the print lines again. And whoops, didn't know that that was a shortcut on Mac. Not even quite sure what I did there. What was the list assign? And I will re-enable the comments, or the lines there. Y.clone appears to be redundant, but a lot of this code will be changing anyway, so it doesn't matter too much, I would say. Okay, so running 0 tests. Oh, index assign, not list assign. So maybe we'll focus on variables index assign. And as we saw before, the output is 2 2. And let's see the values that get declared here. So we should be in a declaration. It'll be done once for print when setting up the general scope environment, and then this will be when we're creating X, and it assigns a list to X and makes a copy of that, and that's in a new location. And then this is the same location as was assigned to X, but we're putting it into a new place as well. Now I'm surprised at that because we're doing a clone, presumably, on X when we're assigning it to Y. So presumably the list would be cloned. Okay, but even the val ref with sources, or even the val refs, are also going to be cloned. So if I get out my tablet again and take a look at what's going on here, let's see. Okay, so essentially what I understand to be happening at this point is that, let's see what, we get out the marker here and zoom in a bit so we get smoother lines. So what appears to be happening is, if we consider X to be this, and it's got, for the sake of argument, we'll say 2 boxes just to make things a bit clearer. And then we assign X to Y, then what happens is we do get a new value. We get a new list gets created. But essentially the things that are inside it are pointing to the same thing. And so when I put 2 into here, that's getting put into both locations. And that's why the same doesn't work with objects, is because essentially the difference with objects is that keys may not exist ahead of time. So at least in the language as it stands, the keys in lists are always defined at the time the list is defined, so you can't overflow or underflow the index. So you can't go out of bounds. Whereas for objects, you can access or assign to a key that didn't exist when the object was created. And so that location will only exist on the new object. And because it's not the objects that are copied, because the references aren't to the same object, but rather to the values. It's difficult to describe in English, at least. Not that I can speak another language that it would be, well, I guess it's easier to to think about in terms of programming languages, but that leaves us with a bit of a problem. Really, what I would like to be happening is not that these are references to the same boxes, but rather that if I go X and Y, that X and Y are individual boxes that point to the same list. So how would I go about doing that? And does this new information highlight a fundamental issue with how I'm handling things at the moment? I mean, I'm glad I introduced this new test as well. I feel like so many of the issues have been flagged just almost by coincidence. I've been adding some extra little tests that independently don't make much sense because they are testing things that seem like they should just work. But thankfully, they've been capturing really problematic issues. So going back to this, we have this situation that's drawn out in the big section, and we want the case that's highlighted in the small section. So what would need to occur for that to be the case? So if I'll shrink this down a little bit and full screen that. And all of these are arc mutexes of value, or if we say valref. I'm going to say value reference with source. And that's what's going to be in that's what's going to be what's at inside a variable anyway. I mean, what we have works, but it, at least in my opinion, doesn't work for the right reason. It kind of works by coincidence for the most part. It's a happy accident. So if I were to, let's see, and this is our scope. We'll have a binding X. And we would say that points to this. It all kind of comes down to the main, I guess the main area that we're working with at the moment anyway is the implementation of scopes and declarations and assignments. And so the solution, we should be able to implement the solution without messing around too much with the rest of the interpreter, I believe. So when we do y equals x, what has to happen? We want that pointer to be cloned. We don't want this to be cloned. So that we have y is this. And it should basically be the same regardless of whether it's an assignment or a declaration, but for the moment we will stick to the declaration logic. So first of all, we have a val. So when we get to this point, we have a valref with source, which is let's see. Oh, there we go. So when we get to this declaration point, we will have a pointer to here, and in theory that will be the pointer from X, but it doesn't really matter. This is what we'll have. At this point. At the moment we're reaching into So we have V. At the moment we're reaching into V. Oh, there we go. To get the list, which is v.v. So we're dereferencing our value, which at this point is an object.list, or an object : list. And so for a list, maybe just adding in the match as I was going to do anyway will keep the same functionality, but with more, I guess, can I do that? I feel like I wouldn't be able to, but we'll see. Oh, that is possible. Yes, so we get the same functionality. We still have 2, but at this point, everything is the same list. So actually, we have gotten the same functionality, and we've gotten it in a more, I guess, in a way that aligns a little better with the expected semantics. So we now have 2 references. They're actually the same reference. And just to illustrate how it would look with something like this. So if in terms of scopes and things like that, so if we have our one layer of scoping and we have X, and when we get to this point of a declaration, there's going to be a val ref with source. So when we come along first time, we're going to have this thing 1, and we're going to have this thing v that points to 1, and then this is essentially v, and then this is v.v, and then if we do v.clone, we're getting a copy of that with its own pointer, and so that's going to be put in, we'll say X here for the moment, and then when we get down to here, we're creating which we don't have a source, so we're just doing a new valref with no source. And that basically, let's see, yeah, that basically just ties us up to that. And then if we were to do that again with this declaration, we would be introducing y. All this stuff is gone. And in this case, v is the reference, v.v is the value. We clone and we get a new value again. We have a pointer, that's x, and this time it gets assigned from y. And so we have two independent memory locations pointing to the same value. So at least in theory, all the semantics are more or less the way that I would want them when it comes to declarations, at least. So what I'm going to do is I'll comment out the print lines, and that should get all of our tests passing. And now it's time to, well, there are a couple of things to do. I will need to, let's see, create an abstraction anyway, because this will need to be reused in assignment, I believe. Yes, because we'll also want to do the same, have the same behavior when it comes to assignments. In fact, those tests will probably need to be so that's variables assign 1 through 6 or 1 through 5. I would probably need to rename those to declaration. And check that the same behavior is kept. Yeah, so let's see if the changing from declaration to assignment flags issues with any of these. So that I think is just a syntax issue. I'm probably missing a semicolon. Yeah. So I think there were 2 tests affected by that. No, so all of those worked well enough. But how about in the object tests? So that's property assignment 4. Property assignment 5 passed because age already existed, and we're back with the scenario where y clones x. So if we were to print out y at this point and x, we would see that they're actually different. Yeah, as is expected based on the logic we have so far, so we need to handle that. So with that all said and done, let's go ahead and start abstracting. Not sure if copy is a reserved word, and I'd say it's not. I could probably name this method copy. So simplifying this. So we have y I'm not even creating a new reference though. So maybe this is more accurate. What I might do is implement it first, and then I'll add the description. to be expected because we still haven't resolved the issue there, but we shall do that now. Looks like I'm doing extra work for now. Not much reason here. And for some reason that didn't resolve the issue with prop assign 4. So it's the same reference, which is what we want in this case. And let's just do this. And we'll also output the name of the thing we're creating. Okay, so we're declaring y, its value is null. We're declaring x, its value is at 3340. Then we're assigning 3340 to y. So let's take a look. Prop assign for line 5. So in theory it should be a reference to the same object. So why is that not getting updated? This would be a prop update. Let's output some more of these debugging symbols. Things are going to get a little chaotic, but it should help us in narrowing down what's going wrong. For that to be meaningful, we would really need to drill into this a bit. Okay, so when we're initializing x, the object is at 6548, and that's being referenced by this address. And we have the same address down here when we are doing an assignment. So that should be y. The variable y, I mean. But this is a different object. Where is that coming from? Okay, yeah, this isn't happening because it's not doing a value copy. So this branch is irrelevant to what we're looking into at the moment. So where is this new object being introduced? And what's referring to it? So if I output the value.v, okay, this is getting a little crazy, but it could help us. I need to give it a distinguishing feature. Okay, so this is a new reference. The references that have been there before are A530, and here we have A5F0. And I'm not sure where that's getting introduced, because in theory we have all the references accounted for. Except for potentially the ones in this file. And maybe this. Yeah, that's probably, yeah, cloning the B tree. So how would I prevent that? Because that's cloning the value inside the slot. So if I were to break out the drawings again, will this connect? Maybe I need to restart the app. Yeah, there we go. So going back to the conceptualization, what will be happening here essentially is we have what? We have our scope, and this would be something like Y, I suppose. And we get a lock on that. We get the valref with source from there. So if we say that's our valref with source and we're calling it slot, and that's that's made up of that's made up of v and source, both of which are references to values. And this is creating a copy of the v that's coming in as a parameter. And then we're getting a copy of v, and then we're cloning what's inside v and putting that inside here. And that's what's currently happening, whereas what I want to happen is to actually replace this entire reference. So we have v over here, and we've now copied it, and I want to replace this reference with that. And so in that way, we're not really wanting to replace what's inside the box anymore, but instead we're wanting to update slot v to our new vref. Does this compile? Again, I don't use Rust often enough to be very familiar with the combination of decorators that I need to use here. Okay, I can borrow that mutably because it's owned by the B tree. Yeah, that makes sense. And going back to the diagram. Well, still, even if it's owned by the B tree, I'm not sure why I can't get a mutable version of it. Oh, that could be why. Okay, so that seemed to do it, and it also gives me more to think about in terms of how I'm actually implementing these changes. So I had been thinking that I would be replacing what's inside the boxes rather than the pointers themselves. I think it would be important here to also do that. In fact, can I do something like this? Yeah, okay. And so if I comment out all these print lines again and try running all the tests again, we shall see where that ends us up. But all other things being equal, we should, if that has us passing all of the tests, then I should be able to copy this logic into the other areas of the bind module. Okay, so I still seem to have some print lines. Oh no, that's just to do with, let's see, is that prop assign in objects? That's prop assign 4, and I just need to get rid of those two calls. But yeah, I can make this public. And we'll try that. And with that done, I can try, for example, doing this. Let's see if that works. If I can't do it like that, then can I do it like this? Might be just the same situation with the mutability again. I wonder. Okay, so that is allowed. Let's try this. Just kind of trying stuff now. And that's not going to work because y is immutable, and even if it did, it wouldn't really be doing what I wanted to do. Yeah. Probably would have to make that mutable. That might be possible now that there's an ampersand involved, because it'll essentially act as a dereference. We'll give it a shot anyway. Yeah, that seems to work now. A little weird, but I wonder, can I do something like that? Or maybe if I did a call using get mute, because that might be the issue. I mean, that basically works on its own anyway. Yeah, I guess it's kind of like the difference between calling get and get mutable. It kind of implicitly makes the lookup a mutable lookup. So yeah, that kind of, so far anyway, puts me in a relatively good spot. It has simplified a bit of the code. And it'll probably be similar. I mean, this will be more like this, and again, yeah, it's gonna be something like that. Alright, see, it says try this, items n as u size. Oh, could I just do it like that? Okay, that makes me feel very silly, but still, if it works, it works. That's cool. Whew. Definitely spent, as always, a lot longer than I expected working on this, but at least now this is probably one of the first time in recent streams where I'm ending the stream not with a bug, at least in theory. So the remainder of what needs to be done now is really more along the lines of cleanup and adding consistency across the binding implementations, and there isn't really a lot to do in that. Like, to a certain extent, there's probably only 10 or 20 minutes in that, but as I know myself, these kind of things can tend to spiral, so I'm going to leave it there. And then once that's implemented, it should be like, yeah, I don't want to tempt fate by saying that the implementation of operator assignment will be made straightforward with all these changes. But that is at least my hope, touch on wood. And then there will be, yeah, there's just a couple of to-do items then And that will be the majority of this language implemented, and it'll be about ready to have the next phase of my next language coming online. So with that said, as is often the case, this kind of went on a bit longer than I expected, but I'm happy with where it is at the moment. Like I said, there should really only be a bit of cleanup to be done and applying these new changes kind of across the board. And then I'll be moving on to the operator assignment shorthand, which is what instigated this crazy detour that has taken, I'd say it's approaching 10 hours of extra work and debugging. But yeah, that's it for today's stream. Thanks to everyone as always for checking this out, and I'll talk to you again.